Last week we started probability lesson. Okay, then we discussed what is the probability. Okay, then we discussed basic concepts regarding the probability lesson. Okay, then today we move into the probability part 2. Okay, then here we discuss joint probability, marginal probability, conditional, and the total probability law. Okay, then first we move into joint probability and the marginal probability. Okay, then here first we are looking at what is the difference between joint and the marginal probability. Okay, then first concept is joint probability. Using the joint probability concept, we can find out the probability of the joint occurrence of the two events. Okay, then here we have two events and we find out the probability of these two events occur together. That is we call as the joint probability. Okay. Then here this table shows then here this table represents the contingency table. Okay. Chapter number 3 we studied contingency table. Okay, then it display more than two categorical variables. Okay, then here this table represents results of the hypothetical survey. In the 10,000 individuals were asked whether they favored increased defense spending. Okay, then there are 10,000 respondents. Okay, then they discuss about the two variables. First one is their political party and other one is they favored increased defense spending. Okay, then they identify what is their attitude about the increased defense spending. It's clear? Then here this table shows two variables. Political party, Democrat and the Republican, their attitude, they identify favors increased defense spending and that does not favor increased defense spending. Understood? Okay. Then here these values are represent how many respondents are there. In the joint probability concept means then here we need to assume then if we need to identify what is the probability that the respondent is a Republican and he or she favors increased defense spending. Okay. Then here we need to identify the probability that particular person, political party and their attitude both together. Then we call it as joint probability. Then tell me how many respondents are there? Democrat and favors increased defense spending. How many respondents are there? Democrat and the favors increased defense spending. How many? 2,500. Then here 2,500 by Democrat and the favors increased defense spending. Okay. Then this 2,500 is a number. Then how to write the probability? How many total respondents are there? Total number of respondents. 10,000. Out of the 10,000, 3,000 respondents are there. Okay. Out of that, 2,500 respondents are Democrat and favors increased defense spending. Understood? This we called as the joint probability. Okay, then under the joint probability concept, we find out the probability of the joint occurrence of the two events. Joint occurrence. Two events are there. These two events occur together. Understood? Why we need to identify that particular person Democrat and favors increased defense spending. And means intersection. Now you know intersection, common elements. Here also same as in here. It's clear? Okay. Then we can say one respondent is a Republican and does not favor increased defense spending. What is the probability? Republican and does not favor increased defense spending. What is the probability? Hurry up. What is the probability that the respondent is a Republican and does not favor increased defense spending? 1,500 over 10,000. Understood? Then these are the examples for the joint probability. It's clear? Then we move into the next concept, marginal probability. Then here, using the marginal probability concept, we can identify the probability of the single event. Here we consider about only one event. Then we take the example, then using same table, assume then we need to find out the probability that the particular person is a Republican. Okay, understood? Then here we need to identify the probability that the respondent is a Republican. Only we consider about their political part. One event is there, no? Only we consider about their political part. Then tell me how many Republicans are there? How many? Republicans? 4,000. Then what is the probability? 4,000 over 10,000. Understood? This probability concept we called as marginal probability. Understood? Then you know in the economic subject you studied marginal utility, marginal cost. What is it? Then here you find out the cost per unit. Now 1 unit increasing. How much cost is increasing? That is thing. Then here also marginal. Same. Okay, then here we consider about the probability of the single event. Understood? Okay, then here joint probability concept, we look in at the more than one events and find out the probability of these given events occur together. Understood? It's clear? Then we move into the worksheet. Here this worksheet represent the one table. That table represents speeding violation and drivers who use cell phones. Then here they identify, they speed the violation, who speeding violation, who no speeding violation, and they identify they are cell phone user or not. Okay, then using this information, then you write the answer for the Roman number 1 and the 2. Hurry up. Write the answer for the 1 and 2. finish. Okay. What is the answer for the Roman number 1? Find the probability that the person is a cell phone user. Then here we consider about only one event. Then which concept we can use in here? Marginal probability. Okay, then what is the probability that person is a cell phone user? How many? How many cell phone users are there? How many? 305. Okay, then total 755. Then what is the answer? 305 over 755. Question asks not the number, question asks about the probability. Then you need to write down the probability. 305 over 755. It's clear? Then Roman number 2 asks what? Find the probability that the person had no violation in the last year and was a cell phone user. Then here, 2 events are there and means these 2 events occur together. It's clear? Then it means joint probability concept. What is the probability? No violation and cell phone use. Then how many? 280 out of the 755. Understood? Okay. Then we move into the next concept we called as the conditional probability. Then here we discuss about the 2 events, but these 2 events do not occur together. In the joint probability concept or intersection, we find out the probability of the joint occurrence. It means there are 2 events. These 2 events occur together at once. Understood? By in here, conditional probability concept, we find out the probability of the 2 events, but these 2 events do not occur together. It's clear? මෙතනදී events දෙකක් තිබ්බට ඒ events දෙකම එකපාර වෙන්නේ නැහැ. That is the difference between joint and the conditional probability. Understood? Okay, then here we can find out the probability of the one particular event. Okay. At that time, another event has been already occurred. That is we called as the conditional probability. We can find out the probability of the one particular event. Okay, then given that another event has been already occurred. මෙතනදී අපි probability එක මොනවා හරි event එකක හොයනවා ඒ වෙද්දී අනිත් event එක වෙලා ඉවරයි. Understood? In the joint probability concept, we find the probability of the 2 events occur together. Understood? Then here we can identify this is the first event, this is the second event. In the joint probability concept, we cannot identify which one is the first, which one is the second. Why? 2 events occur together. In here, under the conditional probability concept, we have 2 events and clearly we can identify which one is the first event, which one is the second event. Understood? Okay. Then here says conditional probability is the probability of an event occurring given that another event has already occurred. Okay, then we find out the probability of the second event. It means first event has been already occurred. Okay, then here we write down this way. Then normally, then we assume there are 2 events. Events A and the events B. Two events are there, event A and event B. Okay, then we assume if we need to find out the probability of the event B, okay, at that time event A has been already occurred. We assume there are two events, event A and event B. Okay, then we need to find out the probability of the event B. Okay, then given that event A has been already occurred. අපි හිතමු අපිට ඕනේ event B එක වෙන්න තියෙන probability එක හොයන්න. A වෙද්දි event A එක වෙලා ඉවරයි. Okay, then tell me what's the first event? Event A. What is the second event? Event B. Understood? Then it means event B is occurred based on the event A. It's clear? A के मतनी B वेला තියෙන්නේ. Why? Now we find out the probability of the event B, but at that time event A has been already occurred. It's clear? Then here we can write down it. Probability of, first we mention what is our second event. Then here what is the second event according to our example? Event B. Okay. Then we write the first event. Okay. Then here, this one is we read it B given A. Understood? Okay. Then here we can say B given A. This is the way we can read it. Okay, B given A. B given A means first event is A, second event is B. Understood? Okay, then we move into how we find the conditional probability. Here we have the formula, how we find it. Numerator, normally in the fraction, there is a numerator and the denominator. අපි කියන්නේ හරය සහ ලවය කියලා. Then here numerator represent what? What is this sign? What is the sign here? Intersection. Okay, then here numerator we write down the intersection of the given two events. Then we have two events A and B. Then we write the intersection. Understood? Denominator represent the probability of the first event. Then here in this example, first event is A, no? Then we can write probability of A. Understood? Okay, then this is the way we can find out the probability of the conditional probability concept. It's clear? Then answer of this formula, we can identify what is the probability occurring event B, event A has been already occurred. It's clear? Then here already this event A has been occurred. Based on that we can find out what is the probability occurring of the event B. A ගේ මතනේ B වෙලා තියෙන්නේ. It's clear? This is we called as a conditional probability concept. Understood? Okay. Then when we use the contingency table to find out the conditional probability, no need any formula. Okay. Then here read the Roman number 3 question. First read it. Third one. Okay. Then tell me, Roman number 2 and 3 are the same question or there is a difference? Roman number 2 and 3, tell me. These two are same or there is a difference? Equations දෙකම එකම දාන්නේ නැත්නම් වෙනසක් තියෙනවා. Question Roman number 2 was find the probability that the person had no violation in the last year and cell phone use. Okay, then and means these two events we need to find out the joint occurrence. And දෙකම කියන එකනේ. It's clear? Then Roman number 3 asks what? What is the probability a randomly selected person is a cell phone user? We need to find out the probability of the particular person is a cell phone user. Okay. Then question says, given that they had no speeding violation. Understood? Then here's use given that. It means these two events do not occur together. And means joint occurrence is there, but here says given that. It's clear? Okay, then first they identify that particular person is they had no speeding violation. Finally, we find out he or she is a cell phone user. Understood? There are two events, but these two events do not occur together. The given word, given that, is the hint word for the conditional probability. You can differentiate these two. Word used and, it means joint occurrence. Given that means these two events do not occur together, it means conditional probability concept. Understood? Then tell me, then here, question asks to find out the probability that particular person is a cell phone user, given that they had no speeding violation. Okay? Then tell me which one is the first event. Which event is already occurred? මොකද්ද වෙලා ඉවරුණු එක? What is the first event in here? Which one has been already occurred? No. They had no speeding violation. First we identify they had speeding violation or not. එයාලා speed එක violate කරාද නැද්ද කියන එක නේ අපි මුලින්ම අඳුරගන්න. After that we looking at they are cell phone user or not. Question specifically says no, you need to find out the probability that particular person is a cell phone user given that they had no speeding violation. Understood? They had no speeding violation. Based on that, we identify that particular person is a cell phone user. What is the probability? Okay, then it's a truth. Then the cell phone user and they speed violate true or not. Okay, but the question asks what? What is the probability that particular person is a cell phone user given that they had no speeding violation? It's clear. Then here, now no need any formula to write the answer. Here first we identify, first event is they had no speeding violation. Then we identify how many of them had no speeding violation. Tell me. 685. Out of that, how many of them are cell phone user? 280. What is the probability? 280 over 685. Why? First event is they had no speeding violation. Then here 685 respondents are there. They had no speeding violation. Then we identify particular person is a cell phone user. Out of that 280 are cell phone use. It's clear. This we called as the conditional probability. Okay, then it's okay. No, then numerator represent intersection. No, then here intersection means cell phone user and they had no speeding violation. Then how many of them are? 280. Okay, then denominator represent first event. First event means they had no speeding violation. How many? 685. It's true. Now clear? Okay, then there is the difference between joint and the conditional probability. Okay, then normally in English grammar you studied if clause, the same as in the conditional probability. Conditional clause, if means conditional clause, no? Understood? Then this is the conditional probability concept. If clause එක මේක උනත් මෙහෙම වෙනවා කියන එක, then same thing in here. Now clear? Okay. Conditional probability now okay? Okay. Then before moving to the next theory part, then try question number 2. This is the general question regarding the probability, okay? Then the last week lesson, then hurry up to find the answer here. Using the basic probability concept and write the answer. Hurry up, write the answer for the question number 2. Finish. Question number 2. The probability that the contractor will get a building contract is 2/3. Okay, then first one says contractor will get a building contract. Okay. Then first event is this one. We say this event is A. Okay. Then the second one, he will not get an electric contract. Okay, then this question says he will get a building contract and the electric contract. No. Then we can say he will get an electric contract. We assume this event is event B. Event B. Okay. Then question is given the probability value. He will get a building contract 2/3. Okay, then this one is 2/3. Then he will get an electric contract. What is the probability? Not get an electric contract 5/9. What is the probability he will get an electric contract? 4/9. Then here we can say this is the 4/9. Okay. Then it means this is the probability of A equal this one here. This is the probability of B. Then what is the next information is given? If the probability of getting at least one contract is 4/5. What is the meaning in here? At least one contract. What is it? How we write the using the probability notation? At least one. It means he will get an electric contract or he will get a building contract or both. That's the meaning of the at least. Then it means he will get an electric contract only. Or we can say he will get a building contract only. Or we can say he will get both contracts. What is it? What is it? How we write it? This is the union. Union means all. Okay. He will get a electric or building or both. Okay. Then the union is 4/5. Okay. Then we can say probability of A union B equal 4/5. Understood? Then question asks what? What is the probability he will get both? Both means what? Intersection. Both means common. Okay, then question asks to find out the intersection. And then here how we find the intersection? Here you can use the additional law of probability. Okay, then you studied union is equal to probability of A plus probability of B minus intersection. Okay. Okay, now you can substitute the answer. Union is given 4/9. Then equal probability of A 2/3 plus probability of B 4/9 minus we do not know the intersection. It's clear? Then you have the simple equation. Simplify it. You can find out the intersection. How we find it? 2/3 plus 4/9 minus 4/9. So here 5/9. Okay, then union we can take it as the subject, then it become positive value. මේ ඍණ value ඍණාගේ මේ පැත්තට positive වෙනවනේ. Then here 2/3 plus 4/9 we can take this union into this side. Then it will become the negative value. Okay? Then what is the answer here? Using the calculator and simplify it, or manually you can do it. I think this is the answer. You can simplify using the calculator, no any issue. Okay, answer is 0.3111. Okay, then this is the probability he will get both. Understood? Okay. Okay. Now clear? Now we studied joint probability, marginal probability and the conditional probability. Next we move into what happened. We have two independent events. Okay, then normally what is the meaning of the independent? Independence, it's not the new word, no? All of you celebrate the Independence Day. Then tell me what is the meaning of the independence? Independent means do not depend on the other. Okay, then here in the probability concept, we first need to check whether we have two events. These two events are independent or not. Okay, then independent means then we assume we have event A and event B. Okay, then we assume these two events are independent. It means one event no influence the other event. Okay, then it means A does not depend on the B, B does not depend on the A. That is the meaning of the independent. එක event එකකින් අනිත් event එකට බලපෑමක් නැහැ. ඒ දෙන්න වෙන වෙනම යනවා. It's clear? These events we called as independent events. Understood? Okay, then here says when events A and B have no influence on one another, we say that events A and B are independent. Okay, no influence one another. එක event එකක් අනිත් event එකට බලපෑමක් කරන්නේ නැහැ. Understood? Then here, if the two events are independent, if the two two events are independent, in the probability concept, they identify some conditions. Okay, then we assume we have two events A and B. We assume these A and B are independent. Okay. There are two events A and B. These two events are independent. It means A does not influence the B, B does not influence the A. Okay. Then here, give me. If the two events are independent, we can directly calculate the intersection. This is the way. If then there are two events A and B or any events, okay, then the given two events are independent, then intersection should be equal to probability of A into probability of B. Understood? If events are not independent, we cannot use this formula to find the intersection. Okay, then previous question, you did question number 2, no? Then here you need to find out the intersection. But question is not mentioning these two events are independent. Here, there you cannot use this formula to find the intersection. You need to take the additional law of probability and find the intersection. Understood? Then scenario specifically saying given events are independent, then you can find out the intersection this way. A into B. It's clear? Okay. Then other concept in here, if the two events are independent, now you studied conditional probability concept. Remember? Then how we find the conditional probability concept value? Numerator represent the intersection of the given two events. Okay? Then here we write down the intersection. Okay? Then what is the denominator represent? Probability of which event? First event. Okay? Then here what is the first event? Event A or B? B. Then this is the formula we can then this is the formula we can use to find out the conditional probability. Then we assume then already we know A and B are independent. Okay. Then tell me if the two events are now independent, how then numerator represent intersection? Then A and B are independent. Okay. Then how we find the intersection now? Section is says A and B are independent. Here you need to write down the intersection. Then how we find the intersection? A into B. Why A and B are independent? Then A, B independent කියලා දීලා තියෙනවානේ. Then when we find out the conditional probability, numerator represent what? Intersection. Okay. Then intersection is equal to what? Probability of A into probability of B. Understood? Then here instead of intersection, now you can write down probability of A into probability of B divided by probability of B. Now what happened? When we simplify it, then the probability of B to probability B, we can cancel. What is the answer here? Probability of A. A means which event in here? Second event. Okay. Then If the given two events are independent, we need to find out the conditional probability. No need any formula. It's directly equal to the probability of the second event. Understood? No need this formula. Then directly you can say this is the probability. It's clear? Then we say, we take another one. Then we have two events. Then tell me what is the answer in here. We assume X and Y are independent. Then what is the answer? Probability of X. Y here second event is X. Then we can say answer is X. Now clear? Okay, then if the two events are independent, these two conditions are fulfilled. It's clear? Given two events are independent, intersection is equal to multiplication of the probability of given two events. Okay, then in the conditional probability concept, it's directly equal to the probability of the second event. Understood? Memorize these things, okay? These concepts. Then the scenario is not specifically saying these two events are independent. You cannot use these conditions. ඒක කියලා නැත්නම් specifically මේ events independent කියලා you cannot use. Understood? Okay? Then try question number 3 here. No any errors in the question. Question is correct. You need to justify these assignments are correct or not. Then here probability values are assigned. Then the assigned values are correct or not. Then tell why. Then using your probability knowledge and write the answer. Any question? Probability එක හොයන්න එයා section එක උඩ ඒක identify කරගන්න ඉස්සෙල්ලා කොහොමද ඊට පස්සේ බලනකොට එයා speed එක violate කරනවා නේද reverse event එක then and no speed in violation. Now we need to identify that particular person. Then not in the right now so we put that one very first stage. ඒක තමයි මම just separate කරන්නේ. විශ්වාස එකේ ගහන්න එක තමයි මම කියන්නේ. Finish. These are the informations given in the question. Okay. And then first says probability of A equals 0.65. Second one says probability of B equals 0.8. Okay. Then these informations are okay. No? Probability of A and the B. Next one says probability of A given B is equal to probability of A. Okay. Then A given B is equal to the probability of A. What is the conclusion we can make now? A is the second event. This conditional probability concept is equal to the second event. It means what? A given B is equal to A. Then the A given B means conditional probability. That probability is equal to the probability of A. Then what kind of conclusion now we can make? Conditional probability එක second event එකේ probability එකට සමානයි නම් මොකක්ද අපිට conclude කරන්න පුළුවන්? Based on that, we can say A and B are independent. Okay. Then before we studied, now if the two events are independent, we need to find out the conditional probability. That one is equal to the probability of the second. It's clear? Okay, then question is given based on the third concept, we can assume these two events are independent. It's clear? Then here, second one says B given A. Probability of B given A. Based on the third point, okay, then we assume A and B are independent. Okay, then based on that particular concept, what may be the answer in here? B given A equal to, based on our assumption, probability of B. Then tell me what is the probability of B value in here? 0.80. But question says 0.85. Okay, then these assignments are correct. That is the way you can explain it. Understood? Based on this third point, we can say A and B are independent. Okay, then using the same events, then you cannot change the first. Firstly, initially says A and B are independent. After that, we cannot say these two events are dependent. Already these two events are independent based on this point. Then we can apply the same concept in the second one. Here B given A should be equal to probability of B. Probability of B equals 0.8. But question given 0.85. Understood? Then we can say these assignments are not correct. Now clear? Question asks, this is a correct assignment of the probability, and explain. Assignments are correct or not, Putha? Then initially question is given the probability of A and B. Using these two assignments are correct or not? එක තැනක independent කියලා අනිත් තැන dependent කියලා ගන්න හදන්න බෑ. Understood? Okay, finish. Then we move into the next concept, total probability law. Okay, then using the total probability law concept, we can find out probability of common division. Okay, then I will explain this one using the example. Okay, then we assume there is a factory. Okay, this factory produce 3%. Factory produce particular product using the 3 machines. Okay, we assume there are 3 machines, machine A, machine B and machine C. Okay, then normally one product is produced by one machine. Okay, then first product is produced by machine A, second product is produced by machine B. Understood? Okay. Then we assume the production rate of each machine, 20% of their total production is produced by machine A. එයාලගේ මුළු production එකේම 100% produce කරන්නේ machine A. We assume, okay. Then 15% of the total production is produced by machine B. Okay. Then here, what is the probability in this thing? 65. Then 65% of the total production is produced by machine C. Now clear? Then normally in the operational process, at the final stage, they identify are there any defective items or not. Normally, final step, they check the quality. They identify the defective items. Okay, manahari issues in items තියෙනවද කියලා check කරනවානේ. Then they identify the defective rates of each product. Okay, then as you machine A, defective rate is 2%. Okay, then machine B, we assume 3%. Machine C, 1%. These are the defective rates. Okay, then machine A produced 20% of their total production. Out of that, 2% are defective. It's clear? Then this meaning is 15% of total production is produced by machine B, 3% are defective. It's clear? Then here 65% of total production is produced by machine C. Out of that 1% are defective. It's clear? Okay. Then here tell me which one is the common event in here. Commonly we can identify what? Then there are 3 events now. What is the common thing we can identify? At the final stage, we identify the defective rate commonly. Okay, then we assume finally we need to select one particular event, one particular product randomly. Okay, then we can identify that particular product is a defective one or not. Understood? Then here item is a defective one is the common event in here. Then මේක machines තුනකින් produce වුණාට ඔක්කොම තියෙන එකම lot එකේ. Okay, then we selected randomly defective item. Then we randomly select one particular product. That product is a defective one. Okay, then we do not know this product is produced by which machine. අන්තිමට dot එකකින් එකක් කරගත්තා ඒක defective එකක් වුණා. හැබැයි අපි දන්නවා මේක මොන machine එකකින්ද කියලා. Understood? Then here we can say if an item is a defective one, this is the common event in here. මොන machine එකෙන් හදුවත් ඒක defective එකක් වෙන්න පුළුවන්. It's clear? Then it means here we need to find out the probability of the common event. Finally, we need to identify the probability of the selected item is a defective one. Okay? Then here we can use this concept. Total probability law. And defective කියන එක machine තුනටම common. It's clear that particular product is produced by any machine. Finally, it may be a defective or non-defective. On a machine එකෙන් හදුවත් අන්තිමට ඒක defective එකක් හරි non-defective එකක් හරි වෙනවා. Understood? Okay, then here we can use the total probability law. It's clear? Then you know the three diagram. pattern, then here we can draw the tree diagram. Three machines are there, A, B, C. On the branch B, represent the probability value. Here 0.2, here 0.15, here 0.5. After that, we can identify defective or not. Then here also defective or not. Here defective or not. What is the no common defect? Item is a defective or not defective. Why we use the same method? It's here. And then here 0.02. Here 3%. Here 1%. Okay. Then assume we need to find out the item is randomly we select the particular item. That item is a defective one. What is the probability? How we write down? D means item is a defective one. We can say probability of the defective one. It's clear. Then how we find the probability? Here we can direct all. This one, yeah, this one, and this one. Okay, and then how we get the answer here? Multiply. Okay, then this probability of E is equal to first one is produced by machine A and defective one. We can say we multiply by these two together, it means intersection. Then plus probability of B, it means using machine B and defective one. Okay, then plus using machine C and it's the defective one. Understood? Then what's the first probability? A intersection is 0.0004. Next one is 0.045. Here 0.0. Sorry, here 0. Here 0.061. Okay. Then we add them all together. 0.05. 0.5. 0.01. 0.015. As the percentage 0.15. In this company, in this factory, what is the defective rate? 0.15%. Understood? This concept we hold as the total probability law. Other thing in here, if we use the total probability law, okay, then the given event should be mutually exclusive and collectively exhaustive. Okay, then if the given events are not collectively exhaustive, you cannot draw the tree diagram. Why? What is the answer in here? Add all together 1. There is no intersection. Common element is not there. It means one particular product is produced by one machine. एक product එකක් හදන්න එක machine එකයි කියන්නේ. එහෙම නැතුව machines දෙකකින් වෙන්නේ නේ. That is the meaning of the mutually exclusive. Understood? Okay. Then the other one is collectively exhaustive. Then it means then all together 100%. 100% means total production. It's a sample space in here. Union is equal to sample space. We can say collectively exhaustive. Understood? Then the given events are not collectively exhaustive. You cannot draw the tree diagram. Understood? Then these two conditions are satisfied. Then we can use the total probability of consent. Understood? Then previously I told there is one particular product produced by one machine. They do not use the two machines to produce one particular product. Machines දෙකක් use කරන්නේ නැහැ එක product එකක් අතර. Okay, then that is the mutually exclusive. And all together it represents the total production. It means they are sample space. Okay, then here we can justify these events are collectively exhaustive. Understood? Okay, this concept we call as the total probability loop. First you need to note down, you can note down it, then we move into the questions. Okay, then if you are finished, then try question number 8. First read the question, then you can use the tree diagram to get the answer. Section number 8. Finish. Okay, then here the group of candidates are competing for the position of the board of directors of the company. The probability that the first and second sets will win are 60% and 40% respectively. Okay, then two groups are there. Okay, then both these two groups compete to the positions on the board of directors. Okay, then first group will win. What is the probability? 60%, 0.6. Then we add these two together. It's equal to 1. It means these two events are collectively exhausting and the mutually exclusive. Both groups cannot be win. Teams it means these two events are mutually exclusive. Understood? If the first group wins, the probability of introducing a new product is 0.8. Okay, if the first group will win, they introduce the new product to the market, probability is 80% chance is there. The corresponding probability if the second group wins is 0.3. If the second group wins, 30% chance is there introduce the new product to the market. Question asks what is the probability that the new product will be introduced? Okay, the new product will be introduced. If the first group or second group will win, both try to introduce the new product to the market. It means introduce the new product to the market is the common event in here. It's clear? Okay, then we can use the tree diagram. Here, first group and the second group. Then here next present, here 40%. Okay. Then first group unit, introduce the new products to the market, 0.8. Okay. Then here 3%. Question asks, what is the probability introducing a new product to the market? Okay, then how many chances are there? Then here we can consider is both events. Okay, then how we get the answer? 0.48 plus 0.12. What is the chance? 0.60. 60% chance is there introduce the new product to the market. This concept we called as total probability. Understood? Okay. Then here, question number 10, only do part A and B. After that, you can take a break. Okay. Then motivation. Only part A and part B. Okay, then part C from the next thing. Section number 10, part A and part B. This section only do part A and part B. Okay. Then this is the tree diagram for that. Then there are three mutually and selectively exhaustive events, three medical coverage. It means one employee has one medical coverage. Okay. Then altogether, it represents the total number of employees. Then first one asks what? If an employee is selected at randomly, what is the probability that the selected employee has standard medical coverage and will submit no claims? Standard coverage and will submit no claims. Okay, then and means intersection. Question asks to find out standard medical coverage and no claim. Okay, then how to write the answer? 0.6 into 0.4. That is the probability. Okay, the next one asks, what is the probability that the selected employee will submit no claim during the next year? No claims during the next year. There are three separate events. Okay, then we have the probability of no claims. Okay, and here we can find out here 0.03. Here 0.24, here 0.07. What is the probability? 0.34 is the probability that the selected employee submit no claim during the next year. Now clear? This concept we called as the total probability law. Part A are only the joint probability intersection. Clear? Then you can take a break. After the break, we will discuss Bayes' theorem. This is the last part in the probability lecture. Here, Bayes' theorem, conditional probability takes into account information about the occurrence of one event to predict the probability of another event. Okay, then the Bayes' theorem is the application of the conditional probability concept. Okay, then here we discuss about the two events, but these two events do not occur together. Okay, same concept in here. Then other way we can say, using the Bayes' theorem, we calculate the revised probability. Here we calculate the revised probability. Then normally we calculate the probability in this way. Okay, then that particular person has the deluxe medical coverage and no claim, submit no claim during the next year. This is but in the when we use the Bayes' theorem, we calculate this revised probability. Okay, then according to this example, the question, then read here part C. Previous question part C. What is he asked? Then here, what is he asked? Part C. If the selected employee submit no claims during the next year. Okay, then question says if the employee will submit no claim during the next year, what is the probability that the employee has standard medical coverage? Understood? Submit no claim during the next year, how many chances? 3 chances are there. But question asks, what is the probability that particular employee has standard medical coverage? Here you need to find out revised probability. Why? First we identify that particular employee will submit no claim during the next year. මුලින්ම අපි identify කරන්නේ ඒ employee BSAA එක ඇතුළත submit කරන්නේ නැහැ කිසිම claim එකක්. Yeah, then after that we find out that particular employee has the standard medical coverage. Understood? Then we can write this. Employee submit no claim during the next year. What is the probability that particular employee has standard medical? Understood? Then how we find the answer here? Numerator represent the intersection. Denominator represent the probability of the first event. Then what is the first event in here? No claim. Probability of no claim. Okay. Then next intersection NC we found 0.24. And then what's the probability here? This is the answer from the total probability law. What is the answer? 0.3. Okay, then you simplify it and you can get it. This concept we call as Bayes' theorem. Understood? Then here we find out the revised probability. Why? First we identify that particular employee submit no claim. After that we find out what kind of medical coverage that particular employee has. Device නේ මුලින්ම බලන්න යාලා submit කරේ නැහැ. එහෙනම් ඊට පස්සේ තමයි බලන්න යාට තියෙන්නේ මොන medical coverage. Understood? Then we calculate the revised probability. We call it as Bayes' theorem. Understood? Okay. Then read the question number 9. Okay. Okay, finish. Why? Then here question says 1% of all individuals in a certain population are carriers of a particular disease. Okay, then it means in Sinhala, rogavahakyo kiyanne. Okay, then here 1% is there. Okay, then the 1% of the population shows the symptoms of the particular disease. එයාගේ රෝග ලක්ෂණ තියෙනවා මොන හරි disease එකේ. It's clear. Diagnostic test of this disease has a 90% of detection rate for caries. Diagnostic test. Okay, then we assume that they test the blood sample and they justify that particular disease is there or not. Okay, then COVID season. Okay, then here they justify do the diagnostic test. 90% detection rate for the caries. person කෙනෙක්ට symptoms තියෙනවා diagnosis test එකනොත් prove වෙන්නේ ඇත්තට මේ ලෙඩේ තියෙනවා කියන එක 90%. Understood? 5% detection rate for non-carriers. Okay? ඒතර සමහරුන්ට symptoms නැහැ හැබැයි detect වෙනවා මේ ලෙඩේ තියෙනවා. It's clear? Okay, then this is the scenario is given in this question. The test was applied to the blood sample from the randomly selected individuals and the test was positive. What is the probability that the individual is a carrier? Okay, then they did the diagnostic test using the blood sample. Okay, then test was positive means what? Then here they identify, no, then first initially say identify carriers and the none. Okay, then 1% carriers here 99%. Okay, then here carriers are 1%. Then they check the blood sample. 1% test was positive. Here 90%. Test was positive 90. These are the non-carriers 99%. But they check the blood sample. They detect 5% of them are test was positive. Under symptoms now, have I tested the current positive? Detect 5% make it. Understood? Then question asks what? They select a particular individual, then they check the blood sample, then what happens? Test was positive. Okay, then you go like any was over again. Blood test එකක් කරාම ඒක positive වුණා. Then there are two. Okay, question asks what? What is the probability that the individual is a carrier? Then here you need to find out the reverse probability. Then which concept you can use? Layer theory. First step, select the individual and check the blood sample. Then what happened? Test was positive. Okay. Then we need to find out the probability that particular individual is a. Here they discuss about the two events, but these two events do not occur together. Okay. So we individuals like number taken for again blood sample check करना. Understood? Then test was positive. After that they identify that particular person has the symptoms also. Then it means that person is a carrier. It's clear? Then how we find the answer? Numerator represents the intersection. Denominator represents the probability of the first state. Okay, then here 1% into 90%. Okay, then the denominator represents both. What is the probability? 0.01 into 0.9, then plus 0.99 into 0.5, 0.0. It's clear? And the answer. 0.1538. Okay. Then finish the probability lesson also. Okay. Then the next lesson is normal distribution, probability distribution. Start करो नहीं